give a high-level presentation, and then there'll be some time for questions at the end. I'll try to go through fairly quickly so I can leave some of that space at the end. And I'll give some background for those of you who aren't familiar with the technology and haven't heard about us before. I also have to show this thing, and I'm assuming you can read really fast and done there. I was going to do some of the background myself, but we recently had some great coverage on CBC. I thought I'd let them give you the overview that they provided. So the first place I'm going to go is the core technology that delivers energy, converts electricity into RF energy, and that's our clean tech inverter. So it's a technology we developed with GE Global Research. It relies on silicon carbide transistors, which is what makes it super efficient at converting energy. And some of the big things here are that we're 97% efficient compared to a typical microwave, something operating at a higher frequency, 915 megahertz or 2.4 gigahertz. So that gives us a big advantage, and that's compared to other efforts that have tried to use microwave energy in this kind of heating space. So much higher energy efficiency at the surface, and that would probably be comparable to the kind of heat losses you'd see in SAGD as well, where we're getting a much higher percentage of the energy delivered at surface into the pay zone compared to either microwave or SAGD steam delivery. It's really flexible as a power source, so it can be turned off and on, used on demand. So, and for intermittent heating, that can reduce both power costs by using off-peak heating, but it also makes it more amenable to the use of renewable power sources to further drive down emissions. We see a huge power range here. We can scale up to 6 or even beyond that, up to 10 megawatts of power, and see some great places where we can retrofit this outside of oil and gas. So there's expansion potential in heavy oil and oil sand production, but we also want to use this engine in other places, and I'm just going to put one slide into what I'm talking about there. With this technology, as we've been doing the testing of the process, we've done tests at 1/4 scale and 1/10 scale. In the past, we've demonstrated that we can heat wet sand and turn the water in that sand deposit, if you will, into steam. And as we look at these other spaces around the world, these other sectors where people are using burning gas to make heat or create steam, in total, they represent 47% of the emissions in the world today. So, to be clear, I'm not saying we can get that down to zero, but we can deliver applications that can start to reduce those and could eliminate emissions for portions of those markets, of huge amounts of emissions that are going in. So we're focused right now on the responsible heavy oil development with our pilot at Marwayne, and then we're looking to expand and take this technology into all of these other markets. So bringing it back to RFXL and the heavy oil space, what are the big benefits here of this technology for producers? Well, they're both economic and environmental. We can turn the heavy oil production process into something that's non-aqueous, so we no longer need fresh water input. The only thing that's going into the ground is power. That simplifies both the cost side of things and improves our emissions, as we need to, we can cut the energy in half because of that efficiency in delivering energy downhole. And we can have a smaller surface footprint because we don't need a steam plant, and we need a much lower, smaller scale of water treatment to process that water and put it back in the ground. And we're lower cost. So the simplicity at the surface takes us to about half the capital cost on a new project, and 40% lower OPEX, and that's primarily driven by simplicity. Our power, as I'll show later, power tends to match gas cost into a SAGD facility. The fuel is the same, the non-fuel OPEX is where we have a big advantage. So what we're talking about here is thermal production with better economics and better environmental benefits. I'm going to dig into it. Here's some much more detailed numbers, but what we're looking at right now is a 2021 view. So you check out the price numbers on the right side, and they're based on a GLJ price deck. This is how we compare to SAGD in a kind of simple 10,000 barrel a day greenfield model. So much stronger IRR, way faster cash flow break even, 2.5 years compared to 14 plus. That's a pretty attractive story, but we also wanted to compare that to what it's like now. Does this advantage go away when we're looking at much higher prices? So starting out with a baseline that's more like $95 a barrel, gas up to over $5, and power at $100 a megawatt hour, so a huge jump in power. And you can see if I go back, we went from $13.50 a barrel OPEX to $18, but we're still well below SAGD because of the gas cost and the efficiency. So we see a real advantage here for operators in getting this kind of reduction in emissions, elimination of water use, and faster time to cash flow break even and profitability. So. Now, for those of you who may be familiar with the technology or followed our story, we've put out a couple of white papers over the years. I find at any conference on almost anything the words game changer gets, that term gets abused a little, so I did want to actually call out some places where this is how we can, as we deliver this technology and prove it out, this is where it can actually change the game. So the back story here is there are 2 white papers. If you want to check them out on our website, they give huge amounts of detail on all of these benefits. The top section is more about the most recent one in 2021, the bottom is about 2020. So number 1, our last white paper was on zero GHG production. In that, we worked with Scovan, who put together a pad-based design, so no CPF, leapfrogging from pad to pad, moving tanks and moving our electronics from pad to pad as you go through the life cycle of each of those wells. Reduced upfront capex and improved economics and smaller footprint in terms of disturbance and time to then reclaim that land. Intermittent heating, so I mentioned this before, but in this case, that white paper, we heated for 12 hours a day. So the idea was to be able to leverage solar power and grid power to find the best economics and the best emissions profile, and only put in energy for 12 hours a day. You double the energy rate, but you put the same amount of energy over a 24-hour period, and our simulations show that's going to get you the same production. That intermittent heating opens the door to, whether you're using renewables or not, it lets you then avoid peak power rates in Alberta. You can go off spot, you can avoid peak power and cut your rates by 30 to 40%. All of that then gets you to near zero scope 1 and scope 2 if you're able to pull renewables into the equation and make them the power source. In that model, we were able to show those could be profitable with an Alberta-based solar facility, and it did get better if you happen to move it to California or the Middle East, but it was still profitable and possible here in Alberta. Another one, now we're shifting to the older white paper, is that we run a low pressure or a lower pressure environment than SAGD because we are not injecting material into the well, we're not injecting oil. We create a lower pressure production environment, and that means we can operate in near surface reservoirs. And that white paper in 2020 modeled about a 55-meter deep, almost mineable resource. So it opens the door to a lot of different deposits that maybe can't be touched today with SAGD. It's not that we need that much more resource, but there's a lot better resource that you could access if you get to open the door on depth. Another thing I'll point out maybe about the pad-based design is a 5,000 barrel a day kind of model. So you don't need to find something that can produce 10,000 barrels a day for 30 years to pay off a CPF. You could leapfrog from 5,000 barrel a day projects to cherry pick the best resource possible. And then overall in both white papers and the entire way the heating works and the production life cycle works in terms of a type curve, we tend to see faster oil production out of the gate from the initial application of heat. And we also eliminate a bunch of the construction time on the front end by not having to build a steam plant on site. We drill and complete wells, drop in the electronics and tanks, and then you can start producing. So now I'm going to shift into the Marwan Pilot, and even for me watching the CBC piece on TV and seeing all those bits of equipment come together, some of the things, it's really wild to see after having worked on this for myself for about 8 years. The company's been on it for 10 years, so I see things that were drawings and ideas, and they're sitting there real, and they're huge and professional with a lot of power running through it. It's pretty exciting, but we've just got a few snapshots of some of the drilling completion process. You saw Jeff being interviewed, I think inside the E-house or inside the office trailer, but that's the E-house on the left that holds the CTI. So the inverter is in there, and that's where the power conversion happens, and it's delivered to out to the wellhead. Another shot of the E-house and some tanks, and that's our first truck of oil, coal production that we had coming out of the wells being delivered. And here's our timeline. So we started site construction. This ignores the 6-7 years to get to this point, but we started construction in Q1 2021. Got into the site itself. Facility construction started at the start of 2022. We put first heat in the ground in March, and then first oil flow, full flow production happened in April, and we're now, as of yesterday, we're really crossing the line on 90 days of heating. Our plan here is to do at least 6 months of heating, and then look at continuing the test. If we're still producing and happy with what we're getting, we want to keep rolling and continuing to see what kind of production curve we get out of the site and learn more from the technology. Now, to get here, we have had help from all of these companies and many more. These have been some of the bigger players in helping us pull this together as a technology company that had to pull together all of the skills and service partners to do everything on site, to get this project done and ground. It's taken a lot of work, and we appreciate everything that all our partners have delivered to us. What's next for us? Number one, this 6-month stretch, we're going to complete the heating at Marwayne. We want to demonstrate that we can get warm oil out of the ground and start to demonstrate that we're heating the reservoir to the extent we predict. We're continuing to work through and ramp up our heating and troubleshoot everything. It's pretty wild to be putting that many pieces of technology that are all the first of their kind working together at once, and then have it be 500 meters down and another 800 across. So it's pretty exciting and going well so far. As we complete that, we're looking to deploy a multi-well demo, ideally in Canada. So we want to get a multi-well experience so that we can really start to quantify what kind of production and recovery factor a standalone RFXL well can do in a given reservoir. We're also looking to kick off our first international project. We've had a lot of interest and we continue to have a lot of dialogue with operators in California, in Latin America, and the Middle East. We're really interested in this technology, and many of those operating environments, they aren't as entrenched really in a SAGD model. Sometimes they don't have water or they don't have gas, so they're looking really for alternate methods of enhanced oil recovery, and we hope to get this going in those markets. As that happens, we're going to be able to shift some more resource into developing alternate clean tech applications. So again, we're looking to decarbonize heating. There's a lot of heating applications out there. I'm surprised every day by new ones that we come across, and the amount of energy that goes into removing water from things we see and touch every day. So that's our story. That's where we're at with the technology and proving it out at our Marwan Pilot, and I'm happy to take any questions.